Okay, this is the first quality of service mutation lab. We're going to do mutation using table maps in a virtual switch. Um, with mutation, you want to solve this problem. You have this network, for instance, network A, where the network administrator decided to use certain markings for the traffic. So in this case, for network A, voice over IP is marked with CS5, video is marked with CS4, signaling traffic is marked with CS3, transactional traffic is marked with CS2, and miscellaneous traffic is marked with CS1. And at network V, the network administrator decided to mark traffic with another set of markings. For instance, voice over IP with expedited forwarding, video with assurance forwarding 41, signaling with assurance forwarding 31, transactional traffic with assurance forwarding of 21, and miscellaneous traffic with assurance forwarding of 11. So we will need a way to maintain end-to-end quality of service per hop behavior at these networks. So for instance, when traffic, for instance, video traffic leaves network A and it is marked with CS4, we will need to remark it as it enters network V with a value of AF41. The same way, video traffic that comes from network V that is marked with AF41 will need to be remarked as it enters network A with a value of CS4. So we will a way to mark CS between CS1 and AF11, between CS2 and AF21, between CS3 and AF31, between CS4 and AF41, and between CS5 and EF. So we will need mutation, and in order to use mutation, we need something that is known as table maps. If you want to know more about table maps and mutation, you can always see your official Cisco documentation. I'm going to include this link in the description. So in this case, I have here a virtual switch where I have network A connected to gigabit 00 and network V connected to 01. So I am going to perform mutation from A to V at gigabit 00 and mutation from B to A at gigabit 01. So let's configure that. Notice that in order to create your table maps, you cannot actually go and type in CS1, CS2, CS3, CS4, CS5, AF11, EF21, EF31, EF41, and EF. You have to use the decimal equivalents of these markings. So in order to perform mutation from network A to V, I'm going to create table map, mutation from A to B, and I'm going to use map from a decimal value of CS1, which is 8, to AF11, which is 10, and then I'm going to map from CS2, which is 16, to AF21, which is 18, and then I'm going to map from CS3, which is 24, to AF31, which is 26, and then I'm going to map from CS4, which is 32, to AF41, which is 34, and I'm going to map from CS5, which is 40, to EF, which is 46. I am using this table here in order to do it faster, and for default I'm going to copy it. So any other CS or DHCP value you will just go and be copied. Then I'm going to create what is known as a child policy map, because in this in this policy map, you can do whatever you want with your quality of service configuration. So it will be child from A to B. So I'm going to leave it empty because it is aimed to perform whatever you want to do with your quality of service as any policy map. And then I'm going to create parent policy map. Parent that is going to perform mutation from A to B. Then as class default, I'm going to do the mutation with set DSCCP table mutation from A to B. So this line is what actually is going to perform mutation, and then I'm going to call your regular policy map. So you can do whatever you want in this policy map, your regular quality of service stuff. The parent policy map is going to perform mutation, and then it is going to call your child policy map. So this is known as hierarchical quality of service configuration. So let's go to gigabit 01. I'm sorry, 00. Notice that 00 is what connects network A to network B. So my service policy at the input will be parent mutation from A to B. So that will be it for the mutation table from network A to network B. So gigabit 00 looks like this. My policy map, this will be my mutation policy map from A to B. It will call this mutation table. Let's see, mutation table, mutation A to B, and then it will call a child policy map where you can do whatever you want. Let's do that in the opposite direction. So in order to do that in the opposite direction, we will have to do table map mutation B to A, and I'm going to have to map from it will be actually the opposite of this table. And then I will create a policy map that will be your normal child from B to A, where you can do whatever you want. And then I will create a policy map that is going to actually perform the mutation from B to A. I'm going to call it, from B to A. And at the class default, I'm going to do the actual mutation with set DSCCP table mutation B to A, and I'm going to call a child policy map where you can do whatever you want. And remember, the parent policy map is going to perform the mutation, and this parent policy map is going to call a child policy map where you can do whatever quality of service configuration you want. And then we are going to attach this mutation policy map to gigabit 01. Notice that 01s connect network B to network A. So it will be service policy input parent mutation from B to A. And that will be it. This will be the configuration for gigabit 00. This will be the configuration for 0, 1, and this will be your policy map from A to B. This will be your policy map from B to A. This will be your table map from A to B, and this will be your table map from B to A. So that will be the way to configure it using table maps. It is easier. However, in order to actually do tests, you will need a real switch. This virtual switch only allows to configure it, but the testing will not work. You will need a real Catalyst 9000, for instance, in order to do your real testing. However, we can delete this switch and configure a direct link between these two routers, and then we could do also mutation at these two routers. However, the configuration is a little bit more complex because we cannot use table maps with routers. I will see how to configure that in the next session.